While previous modules established the intelligence layer for when to order a part, this session focuses on the physical logistics of the warehouse itself. In most facilities, even if the correct part is in stock, the time taken to locate, verify, and transport that part to the machine creates a massive amount of information and physical latency. You will learn that a disorganized warehouse is a primary driver of extended downtime. If a high-speed production line stops, every minute spent searching through the dusty bins or unlabeled shelves is a minute of lost margin. The Asset Intelligence Framework treats the warehouse not as a storage room, but as a pit stop in a high-performance race. The goal is to eliminate every second of waste movement so that the surgical repairs discussed earlier sessions can be executed with maximum speed. The first step in optimizing the physical space is the implementation of criticality-based storage. In a standard warehouse, parts are often organized by size, weight, or a legacy numbering system. This is a failure of operational logic. You will discover how to recognize the warehouse based on the risk-weighted metrics of the facility. High criticality spares, the components that protect the critical path of production, must be stored in the golden zone, which is the most accessible area of the warehouse. Conversely, low criticality items or consumables with high lead times can be moved to the perimeter. This reduces the travel waste of the maintenance team and ensures that when a $1 million second occurs, the required solution is physically closest to the exit. One of the most effective ways to reduce downtime is the transition from picking to kitting. In a traditional setup, a technician receives a work order and then spends an hour gathering variable bolts, seals, and specialized tools from different areas of the plant. This process is prone to error and creates significant latency. The Asset Intelligence Framework utilizes the predictive data from the AI Copilot to trigger automated kitting. When the system identifies an impeding failure, it doesn't just order the primary part. It generates a full intervention kit. This kit includes every gasket, fastener, and specialized tool required for the specific physical intervention. By having the kit pre-assembled and ready at the warehouse gate, the maintenance team can move straight to the asset. This turns a complex mechanical repair into a standardized Formula One style component swap, protecting the delivery schedule from human error and missing small parts. The optimization of spares also extends beyond the four walls of the facility through vendor-managed reliability. Instead of the traditional model where a vendor simply sells a part, this framework creates a data-sharing partnership. You will see how providing vendors with access to the health scores of your assets allows them to manage your inventory levels for you. If a vendor knows that a critical motor in your facility is entering a deterioration phase, they can proactively move a spare to their local distribution center or even your own site before you even place the order. This shifts the carrying cost of the inventory back to the supplier while maintaining the highest possible level of protection for the plant. It transforms the relationship from a transaction into a synchronized reliability strategy. To maintain information integrity in the warehouse, the framework utilizes a digital twin of the inventory. This is a live three-dimensional map of every part, tool, and consumable in the facility. By using NFC tags and automated scanning at the point of entry and exit, the system eliminates the ghost inventory problem, where the computer says a part is in stock but the shelf is empty. This digital layer provides the AI co-pilot with perfect visibility into the physical readiness of the facility. If a repair is needed, the system can instantly verify not only that the part exists, but its exact location and its current shelf life status. This ensures that no repair is ever delayed by a data discrepancy. The challenge for this session is to perform a shadow study on the next unplanned repair. Track the technician from the moment the machine stops to the moment the first tool touches the asset. How much of the time was spent walking, searching, or waiting for the part? You will find that by optimizing the physical warehouse and implementing kitting, that response latency can be reduced by 50% or more. In the next module, the focus shifts to the final strategic layer of the framework. Module 16, the strategic maintenance audit. This is where the entire maintenance strategy is reviewed and refined to ensure it remains aligned with the commercial goals of the business.